Currently, the biggest problem in physics is that there is a conflict between Einstein's theory of relativity and quantum physics. These two theories just do not talk to each other. The problem arises when we look at space-time at smaller scales. According to general relativity, space-time is totally smooth, but quantum mechanics ensures that space can never be smooth at smaller scales. And physicists hate this. The whole idea of physics is to provide a single description of the world. And now they seem to have two contradictory descriptions of the world. Many physicists are working on this problem as we speak. And one such physicist is Dr. McCulloch, who works as a lecturer in Geomatics at Plymouth University, UK. We discovered an awesome scientific paper from Dr. McCulloch where he has shown that Newton's gravity law can be derived directly from Heisenberg's uncertainty principle. Now this is pretty amazing. The paper is just 2 pages long and any high school student can understand it. Let's see how it works. Consider a mass small m and a mass capital M orbiting around each other. Now consider two Planck masses, one within mass small m and one within mass capital M. Since we are in quantum realm, so Heisenberg's uncertainty principle is applicable here. The total uncertainty of the two particles will be twice that of a single particle. So we get this. Now let's assume that mass small m has n Planck masses. Similarly, mass capital M has n Planck masses. Therefore, the total average uncertainties over all Planck masses in the two bodies can be written as this. We also know that energy is equal to momentum times the speed of light. So we get this. Here, let's assume that the uncertainty of the average position delta x between various Planck masses is the separation between the two bodies, which is basically the orbital radius r. Now work done is force times the distance moved. So we get this. Again, delta x is the orbital radius. Double summation on the right side is equal to the number of Planck masses in mass small m times the number of Planck masses in mass capital M. So we get this. Here you can see this equation has the form of Newton's gravity law. Since Planck mass mp is equal to square root of hc by g, we get this. This is Newton's gravity law derived from seemingly unrelated quantum theory. How cool is that? We can understand this intuitively as well. According to the uncertainty principle, if the uncertainty in position decreases, the uncertainty in momentum increases. Now, if the radius of orbit decreases, the uncertainty in position decreases. Therefore, the momentum must increase. By summing up the uncertainties over all the Planck masses, we arrive at the law of gravity. Of course, Newton's theory of gravity has been superseded by Einstein's general theory of relativity. However, Newton's formula still works for small, slow-moving objects. So this derivation is still valid for small, slow-moving objects. Moreover, it indicates that gravity is intimately connected to quantum physics, more specifically the uncertainty principle. We will love to hear your thoughts on this paper. Please let us know in the comments below.